Welcome dear students. In this video I am going to explain about ray diagrams for formation of images in a spherical mirror. Children, when an object is placed in front of a spherical mirror, several rays from the object incident on the mirror, and after reflection they forms the image in the mirror. To draw the ray diagram, we will use some convenient rays. Out of these, we will use any two to draw the ray diagram. So let us first learn convenient rays for the construction of image by ray diagram. In this, the first one is a ray passing through the center of curvature. So what happens to a ray when it incident through the center of curvature or directed towards the center of curvature? So let us see. When a ray of light is incident through the center of curvature, after reflection it will be reflected back. It will retrace its path. If it seems to come or seems to go through the center of curvature, after reflection it will be reflected back along the same path. So this is the first rule. When a ray passes through the center of curvature, after reflection it retrace its path or bend reflected back along the same direction. Second one, a ray parallel to principal axis. If a ray incidents parallel to principal axis, like this, in concave as well as in convex. So after reflection, it will pass through the focus. It will pass through the focus, or it appears to comes from the focus. So it just seems to be coming out from the focus. So when a ray parallel to principal axis, after reflection it will passes through the focus or appears to comes from the focus. The third point, when a ray incident or passing through the focus. So just opposite of the second case, when a ray of light is passing through the focus, let us see, this is the incident ray. So after reflection it will become parallel to the principal axis. So this is the direction when it passes through the focus. After reflection it will become parallel to the principal axis. In this, again, if it seems to be pass through the focus like this, after reflection it will become parallel to the principal axis. The next and the last one, when a ray incident at the pole, look at this, when it incident at the pole, so it will be reflected back according to the laws of reflection, and this principal axis, x dash x, the principal axis is a normal. That means this angle is the angle of incidence and this angle is the angle of reflection. Similarly, if a ray of light incident on the pole, after reflection it will be reflected back. Principal axis is the normal, so this is angle of incident and this is the angle of reflection. So these are the four convenient rays which we can use any two to form the image in spherical mirrors. Now let us see the ray diagrams for formation of images in a concave mirror. So in this we will see different positions of object positions of image, nature and size of the images. So let us start. In this, the first we will see when the object is very far from the mirror, that is, let the object is at infinite. When the object is at infinite, the ray seems to be comes parallel to the principal axis. So as we have studied, we can use any two convenient rays for obtaining the image. So let us see in this. Two rays we have considered, they are coming parallel to principal axis. They are coming parallel to principal axis, means the rays from the object which is at infinite seems to be comes parallel to principal axis. After reflection, they passes through the focus. So image is formed at focus and the size of the image will be very small. It will be a point size object, point size image. As the reflected rays are actually intersecting at point F, so the image formed at focus will be real and inverted. So we can say the position of object is at infinity, position of image is at focus, nature of image is real and inverted, and size will be a point size object. If the object is very far, not at infinite, that means very far from the object, very far from the mirror, then what happens? The rays again seems to be comes parallel. But in this, the rays were parallel to principal axis. In this, the rays are incident parallel on the mirror but not parallel to principal axis. Then what happens? These rays, when incident on the mirror parallel, after reflection, they appears to intersect at the focal plane. So image is formed at the focus, that means on the focal plane image is formed, but distance we will measure from the pole then at the focus. So the position of object is very far from the mirror, position of image at focus, size it is very small, so diminished size, nature real and inverted, because reflected rays actually intersects after reflection. The third position we will see when the object is kept beyond the center of curvature. Then to draw the ray diagram, we will take two convenient rays. So first I am taking parallel to principal axis. The rays parallel to principal axis after reflection passes through the focus. One more ray we will take, that is passing through the center of curvature. So as we know, when the rays incident through the passing through the center of curvature, after reflection it will reflected back along the same direction. So it intersect between center of curvature and focus. So the image is formed between focus and center of curvature, and this image is also real and inverted. So we can say the position of object beyond the center of curvature, position of image between C and F, nature real and inverted, and size will be smaller than the object. Next, when the object is placed at the center of curvature, then again we use the same two convenient rays as I show in this diagram. One parallel to principal axis and one passing through the center of curvature. Or in this I use the two one parallel to principal axis after reflection passing through the focus, and one ray is incident or passes through the focus. After reflection, it becomes parallel to principal axis. So the position of object is at center of curvature. The position of image is also at center of curvature. The nature of the image is real and inverted. The size is equal to the size of image is equals to the size of the object. So this is the position of image when the object is at center of curvature. Next, when the object is placed between center of curvature and focus. So again we will show two rays, one parallel to principal axis. At least two we can take, two rays we can take, passing through the focus, okay, and one ray we will show which is passing through the or incident on the mirror through the focus. When it incident through the focus, after reflection, it will becomes parallel to the principal axis. So reflected rays are intersecting at this position. So image is formed at this position. It is A dash B dash is the image. So we can observe from this diagram the position of object is between center of curvature and focus. The position of image is beyond the center of curvature. The nature of image is real and inverted, and size is bigger than the object, means it is magnified. Now let us see the next position. When the object is at focus, so we will take again two rays, at least two rays we will take. The first one we can pass through the parallel to the principal axis, so it passes through the focus. It passes through the focus. One more ray we can take, I am showing, which is incident on the center of curvature. So when it is incident through the center of curvature, it will be reflected back, and these rays becomes parallel. When these rays becomes parallel, it means the position of image is at infinite. So we can say the position of object is at focus, image is at infinite, nature real and inverted, and size will be magnified. Now the last position, when the object is kept between focus and pole. So two rays I have taken in this, one parallel to principal axis passing through the focus, and one ray passing through the center of curvature. When we produce in the backward direction, then they appears to intersect behind the mirror. So image is formed behind the mirror, and the reflected rays appears to meet. So the image formed is virtual, erect, and it is magnified. So children, there is only one case in concave mirror in which the image formed is virtual, that is when the object is placed between focus and pole, the image formed is virtual, erect, and magnified. And all the rest cases, if we have seen, the image formed is real and inverted. Now we will see the image formation by a convex mirror. Let us see the ray diagrams for formation of images in a convex mirror. So in convex mirror, we have only two positions. The first one, when the object is at infinity, then the incident rays seems to be parallel to the principal axis. So when the rays are parallel to the principal axis, after reflection they diverges and appears to diverge from the focus. So image is formed at the focus. As the reflected rays appears to diverge from the point F, so at point F the image formed is virtual, erect, and it will be a point size image. So the position of object infinity, position of image at focus, nature virtual, erect, size a point size object. Next case, when the object is placed in front of a convex mirror, let AB is the object, we will represent this diagram by two rays, two convergent rays, one parallel to principal axis and one is incident on the pole. So what happens? At the pole it will be reflected back, and one parallel to principal axis it will be divergent. When we produce the reflected rays in the backward direction, they appears to intersect between pole and focus. So image formed is in between pole and focus. The image formed is virtual and erect. The size of the image will be smaller than the object. So in this we can say position of object in front of mirror, position of image between pole and focus, nature virtual and erect, size smaller than the object. So this is all about ray diagrams. In next video I will explain about the uses of concave and convex mirror. Thank you students. Thank you for